So your first thought on this one is that it looks like it's in arctan form because, you know, it's got something plus something squared on the bottom. And because we're in, you know, inverse trig integrals, you might be like, yeah, of course, that's arctan form. But guess what? This has an x on top. This is an x on top. And so this is not arctan form because arctan form does not have an x on top. It just has some number, any constant on top, right? And in this case, it has an x. So what do we do? And you're going to be overthinking this, but think about, do you see a function and that function's derivative? Yeah, I see this function 3 plus 4x squared. I see that function, so I could call that u, and I see its derivative. The derivative of that function is 8x, right? So du equals 8x dx. So therefore, I can do a U-substitution here. All right, so a U-substitution for this one, du, let's see, dx equals du over 8x. So, hang on for a minute. Okay, so dx equals du over 8x. So we replace that, so we have 1 over, or 8x, excuse me, 8x over u du over 8x, right? Now the 8x's cancel out, and I get the integral of 1 over u du, which equals ln of absolute value of u plus c. And what is my u? My u is 3 plus 4x squared plus c. So that is my final answer. We did not even need trig substitution. In fact, we couldn't do it because we had an x on top. So let's look at number 5. Again, we have an x on top. So this is not a trig substitution issue. This one, if you remember, when we have the same power on top and bottom, we have to use long division. I know you love it. It's so great. Okay, so let's do long division. We have 8x squared divided by 3 plus 4x squared. Well, that goes in 2 times. That gives us 8x squared plus 6. When we subtract, we get 0 and negative 6. So we have minus 6 over 3 plus 4x squared. Okay, so this is the same as the integral of 2 minus 6 over 3 plus 4x squared dx. Okay, so we can rewrite this as 2 separate integrals, right? We can rewrite this as the integral of 2 dx minus the integral of 6 over 3 plus 4x squared dx. Okay, so this first one's really easy because the integral of 2 with respect to x is just 2x. So this is just 2x plus c. The second one is not so easy because we don't know how to do this, right? Because there's not an x on top. Well, we do know how to do this. We learned just today. This is a trig substitution. It is in the form of 1 over 1 plus u squared, or it's close, right? So this is arctan. This is an arctan. So let's figure out what, let's get it into that form. Okay, and we already kind of did this. So 6 over 3 plus 4x squared. 6 over 3 plus 4x squared. Okay, so let's divide by 3. So we have 6 over 3 times 1 plus 4x squared over 3. We can simplify that. So now this is 2 over 1 plus 4x squared over 3. Okay, so we're really close to now being in the right form, but we need to get this as, I'm pointing at it as if you can see it, this right here as some quantity squared, right? So what squared equals 4x squared over 3? Well, remember it would be 2x over root 3. We kind of figured that out on our last one. So that equals 2 over 1 plus 2x over root 3 squared. Okay, so now we're in a form that we can do a trig substitution. So let's go ahead and put this back in here, and we're going to have, let's see, so let's just do the derivative or the integral down here. What is the integral of this? Well, if u equals 2x over root 3. Then du equals 2 over root 3 dx. And dx equals root 3 over 2 du. Okay, and then we can just go ahead and rewrite this as 2 times the integral of 1 over 1 plus u squared du. And then we've got that root 3 over 2, so we have root 3 over 2. Okay, so we end up with root 3 times the integral of that, which we know, what's the integral of 1 over 1 plus u squared? Well, that's arctan. So we can write arctan of u plus c, okay? And then what was u? Well, u was 2x over root 3, so this equals root 3 arctan of 2x over root 3 plus c. Okay, so now this is our other half, right? We already found that the integral of 2 was 2x, and so now the other half is minus root 3 arctan of 2x over root 3, and then we got to tack on just 1 plus c. We don't need both of them. This one's a little bit tricky because it's not really obvious. You don't really see, like, you see a function and its derivative, but those wouldn't cancel out because you have that plus 4 there. So a lot of times when you have like two things adding together on top of a fraction, a lot of times you're going to split the fraction into two fractions. Not always, but it's usually pretty helpful. So let's go ahead and try to split this into two fractions, because remember, I know this is going way back, but if you have 3/5 plus 7/5, that equals 3 plus 7/5, right? So I can go backwards. I can split a fraction. If I have something that looks like this, I can split it. As long as I keep the denominator intact, I can split it. So we're going to do that. So this is going to be the same as the integral of x over square root of 4 minus x squared dx plus the integral of 4 over the square root of 4 minus x squared dx. Okay, so I just split it into two fractions because it's just this fraction plus this fraction, and they're going to stay intact. Okay, so now I see a function and its derivative, so I'm going to take the U-substitution and I'm going to substitute that in so I can cancel that out. So we'll do that over here on the left in blue. So we have u equals 4 minus x squared du equals negative 2x dx. Therefore dx, oh, that was ugly, dx equals du over negative 2x. Okay, so let's do our substitution. So we have, that's then the integral of x over u to the 1/2. Let's rewrite that as u to the negative 1/2. So we have x u to the negative 1/2. So that's u to the 1/2, and then we have du over negative 2x. Whew. Okay, so the x's cancel out, and we end up with negative 1/2 on the outside times the integral of u to the negative 1/2 du. Okay, so what do? We add 1, so we have negative 1/2, so that becomes u to the 1/2, and we divide by 1/2. And so then that would end up being 2, so we get negative u to the 1/2. Whew! Okay, so that is one of them. Okay, and then again, remember that u was 4 minus x squared. So here in purple, I'm going to write what the final product was. You can't see that. Okay, so the final product was 4 minus x squared to the 1/2. Okay, that is our first integral. Now let's do the second integral in this. Okay, now this one looks like a trig substitution because we have this, it looks like arc sine, right? Something minus something squared. So let's go through this whole process. Okay, so we're going to bring the 4 outside the integral first. we're going to have 1 over the square root of 4 minus x squared dx. Okay, now we're going to get this, instead of to be 4, we want this to be 1. Okay, so we have 4 times the integral of 1 over, and so we're going to have the square root. We're going to bring the 4 outside, and we're going to get 1 minus x squared over 4. Okay, because I just divided both of them by 4, and I end up with x squared over 4. Okay, now I'm going to realize that I want this to be x squared over 4. I want it to equal some quantity squared, right? So that I can have a U substitution. So this is 4 times the integral of 1 over square root of 4 times 1 minus, that's going to be x over 2, all of it squared. Okay, because that would then be in the sign form, right? And now I can just do a U substitution. I can do a U substitution here where U equals x over 2, du equals 1/2 dx, therefore dx equals 2 du. Okay, so I'm going to come back over here and I have 4 times the integral of 1 over, oh, I forgot to take that 4 out. So what's the square root of 4? Well, it's 2. It's 2. So I'd have a 2 here, but let's go ahead and bring that 2 out here. Square root of 1 minus u squared times 2 du. Okay, so now we're going to bring that 2 out. So I have 8 over 2, which is 4, times the integral of 1 over the square root of 1 minus u squared du. Now this is in the exact form of arc sine, so now I can just say 4 arc sine of u, because the integral of this is arc sine of u plus c. And now we know what u was, right? U was it x over 2? Let's make sure. Yep, it was x over 2 plus c. Okay, so we have our two integrals solved, and we can just put them together now.